Well, hello everyone. Sorry, my microphone wasn't turned on initially, but we are doing, this is WCA Physics. So we are doing Unit 4, Lesson 5 on the second law of motion. There isn't a lot of math in this one. I think you'll be happy right away anyways. But what we are looking at is kind of a description, a mathematical description of inertia. So Newton's first law and Newton's second law really go hand in hand. Newton's first law told us that inertia was the resistance to motion an object has, right? That it takes force to be able to move an object. It has resistance to motion that's proportional to the mass. So mathematically, we can define this using Newton's second law. So our terms here are acceleration, linear, mass, net force, Newton's second law, and velocity. So if we remember, really it just goes in to describe what Newton's second law is. What I want you to know about Newton's second law is the equation that force is equal to mass times acceleration. Net force equals mass times acceleration, right? And there are three sides of a triangle. So if I increase the force, what ends up happening, I'm going to go ahead and write this because I think it's a little easier sometimes to write it. So force equals mass times acceleration. What this is saying is that if I have a very, very massive object, it's going to require a lot of force to get it to accelerate. And if I want to have greater acceleration, I have to increase that force. So the larger the force, the greater the acceleration. Let me just write that one down. So if I increase the force, proportionally, the acceleration goes up. They are linear to each other, right? Increase force, you get a greater acceleration. However, if I end up with a much more massive object, if I increase the mass, the acceleration is going to go down proportionally as well, as long as I'm applying the same force. So while I'm applying the same force, if I increase the mass of it, I'm not going to be able to get it to go as fast. So the acceleration goes down. So the force is directly proportional to the acceleration, and the mass is inversely proportional to the acceleration, right? So we just have to kind of keep that stuff in mind. It really, like I said, is a mathematical descriptor of inertia. If an object has more mass, it has more inertia. The more massive the object is, the harder it is to move. Therefore, the greater the force you need to get it to move. And if I want to increase the acceleration, or if I want it to move faster, then I have to apply a greater force to it to get that to happen, to get it to move, to get it to change directions. So that is the essence of Newton's second law. And so you can kind of see here, as I increase the acceleration here, if we look at this at 1.2, the force of 1.2 newtons, I require this acceleration. At 0.7 newtons, it's a little bit greater than half, my acceleration goes down. So we see that proportionality expressed here as well. And that's pretty much it with Newton's second law. I mean, it's a pretty easy law to understand. You can graph it. You'll be doing some more work with it in here while you're looking at graphs and looking at some simulations. But just to understand that, remember that force is measured in newtons, mass is in kilograms, and acceleration is in meters per second squared. So just kind of remember that. So whenever you're doing problems like that, if they are not in the correct unit, you have to get them into the correct unit. How does mass and force relate? Force is equal to mass times acceleration. We just said that, right? But if you don't know we also can say that force, the weight of something, is equal to mass times 9.8 meters per second squared, that gravitational acceleration. So just remember that little g is also acceleration. It's just acceleration due to gravity. So if I want to know the mass of this, I would measure it in kilograms. But if I want to know its weight, I would take that kilogram measure, multiply by 9.8 meters per second squared, and get the weight of it in newtons. And weight is a force. It is pushing, pulling down with the weight of the apple. All right, that is it for this lesson. It's a real short one today, ladies and gents, and hopefully you understood that. If you have questions, let me know. Otherwise, I will see you in the next one.